Our second topic for today is scientific notation. This is a notation that is used to describe very, very, very big numbers, like perhaps the number of feet it is from here to the moon, or very, very, very small numbers, like the number of inches across that an atom is or an electron is. So these concepts will be used frequently in your science classes. So rather than writing lots and lots and lots of zeros to make a number very large, or zeros after a decimal before the non-zero digits to write a number that's very small, we use this short notation that's called scientific notation. So to explain it in mathematical terms, we say that a number is in scientific notation if it's in this form. It has a number in the front, and then it says times 10 raised to some kind of power. And the rules for this are that the A has to be between, it can be 1, but it can't be any bigger than 10. So it has to be a single digit number. And then if there are other digits in the number, they would have to come after the decimal point. So 1.5 would fit this definition. 1.7983 would fit this definition. The other piece of the definition is that it's the absolute value of A. So what we mean by that is that it's okay if A is negative as long as, when it's in its absolute value form, it only has one single digit in front of its decimal place. Okay? The other rule with this, and this is why we have the scientific notation section following the sections we just did, is that this n has to be an integer, meaning that n can be any whole number, positive or negative. So this will probably start to make more sense when we talk about it a little bit. So let's look at numbers that are in standard notation, how we would get those into scientific notation. So if you're given a number that's in standard notation, you're going to count the number of places that the decimal needs to move to have only one digit in front of the decimal. So if you had to move the decimal to the left, taking a very tiny number, 0.00000076, and you needed to move the decimal from the left over here to the right, then you're counting the number of digits that you're making it bigger. So to turn it back into its scientific form, it would have to go to the left. So very, very small numbers end up with a negative n. Very large ones end up with a positive n. So this number of places that you move, this is the n in our a times x times 10 to the n. Going the other direction, you've got a number that's already in scientific notation, so it's already in the form a times 10 to the n. N tells you how many spaces or places to move the decimal. So if n is a positive number, if it's a positive n, move decimal to the right. So by moving to the right, you're making that number bigger. So positive n's in the scientific notation are going to create very, very large numbers. If n is negative, move decimal to the left. So numbers written in scientific notation that have negative n's are very, very small numbers. They're 0.000 before the significant digits begin.